Yeah, very pleased to be here today, and thanks to the SIG for inviting me. Today I'm going to talk about Bluetooth beacon networks, and first focusing on the ones we might all be familiar with, such as the Apple Find My network, Google Find My device networks, which are like very prevalent and in all of our lives, and I bet like a few of you have like AirTags in their bags and stuff like that. And I'll look a bit more at a more emerging space, which is the commercial asset tracking side of those networks, and why this is a very exciting space to be, and what we're expecting to see both technically and in the ecosystem as in the coming years and now as well. So first, let's start with those consumer networks. Um, I mean, who hasn't used an AirTag or a tile or something like that, right? Like those are everywhere. Like I just looked back, like when I was prepping this presentation, and it seems that they've been there forever, but the AirTag was only launched in 2021, and at the time I managed to recover a suitcase from an airline that had lost it in Dublin airport, and they finally shipped it to me because I was able to tell them where it was, which sounds a bit crazy, but since then, I've been using those like a lot, as a lot of you might have. And two main networks in the space are the Apple Find My network and the Google Find My device network. And if you look at like sheer number in terms of the number of handsets and devices providing coverage, so like the number, like basically mobile phones that are onboarded on iOS or Android and have the right technology to provide that coverage, well, the numbers are a bit insane, right? Like if you look at the number of zeros on that chart, it's like we're talking about billion devices because iOS, Android are so prevalent in terms of deployment that overnight, Apple and Google were able to unlock like massive networks to provide coverage for consumer applications. And there are other networks out there as well. Samsung have their own thing, Tile as well, and that looks a bit tiny, but it's not. That's still pretty big numbers. Just that the scale of those two big ones is a bit insane, and it really shows how like the sort of power of Bluetooth and how ubiquitous that is, and how overnight you can unlock like crazy capabilities like that, thanks to its pervasiveness. So if we just look briefly at how it works, the overall concept is pretty basic. You have things that look like a beacon. They broadcast some kind of identifier. That identifier gets spotted by a mobile phone which is nearby, and the mobile phone is aware of its location and can share the identifier and its location with a cloud platform that manages the network, and then the end user who owns the tracker, the beacon, can interrogate the cloud platform and get ask, okay, here's my beacon ID, where is it, and they can get the location back. So that's a very high level overview. Obviously, it's a bit more complex. So what happens actually when you buy an AirTag or something like that and open it and pull the little battery tab? Well, that AirTag has already been provisioned by using some Apple root of trust, and there's the same equivalent process for Google managed devices, and that enables them to create a pair, like a sort of simple pairing thing based on proximity, and we can argue how secure that is. But they establish a shared a pairing credential based on the fact that your phone and the device share like the same root of trust, and your phone establishes a pair connection, and then two key things are exchanged between the device and your phone. First, a shared secret, which is generated on the phone, and also the notion of time. So from now on, your AirTag or your tracking device, your beacon, will know what time it is, which for security-related stuff is pretty important. So the shared notion of time, the shared secret, and that's sort of mediated in the background by the manufacturer who's managing the network. And actually, when I said your tracker, your AirTag would broadcast an identifier, I lied a little bit. Actually, it's broadcasting an ephemeral public key. And the reason why it's ephemeral is that it sort of prevents your beacon from being easily spoofed, so it rotates once in a while. The trade-off with that is that you don't want it to rotate too often, because if you're the owner of that phone, which is spotting that device, you don't want to be tracked by that beacon, so you want to be able to detect if the beacon is following you. That's why you might have got like a notification on your phone. Like I get those quite often after being on a flight. That device has been found traveling with you. It's because that public key doesn't change that often, so your phone is able to see, oh, that thing's been next to me for a while. Am I being tracked? So there's that kind of requirement, which is a bit in conflict with itself, between like not being able to spoof devices, but also from a phone standpoint, like the person next to that tracking device, can I detect that I'm being tracked myself? And what the phone does, like which is on the network, is use that public key to encrypt its location. It's aware of its location and sends its location to the cloud. And so if we dive into how that works from a cryptographic standpoint, basically the device is aware of time. So based on that, it can, based on the time and the shared secret which was exchanged earlier, it can derive an ephemeral public-private key pair. So on the device, only the public key is used, and that's the one which is broadcast. And then, as I said, the location from the phone which would have spotted it is encrypted and sent to the server that's managed by Apple or Google. And then, as a user, as the device's owner, you can basically go through the same process. So you derive this time the public key and the private key. Your phone will do it for you, like because it has access to that shared time, has access to that shared secret, so you can go through the same process and derive the corresponding private key, and then it asks the Apple server or the Google server, hey, is there any location information or updated sighting associated with that public key? And the server will, if it has one, return it and return an encrypted location. And because you're able to derive the private key, you can decrypt the location, and now you know where your device is. Okay, why did they come up with such a complex scheme? Well, the key thing is, if you want to roll out like coverage using all of the iPhone and Android phone users in the world, you want to make sure that there's some element of privacy in terms of them not feeling that they're being tracked, right? That their phone is not being tracked. So it's all about like acceptability from the consumer standpoint. You don't want Apple to know where your phone is. You don't want Google to know where your phone is. So the idea is that because all location information is encrypted in the Apple or Google backends, Apple or Google is not able to decrypt that data, so they can't know where you are, and beyond that, even if someone was going to hack those databases, they couldn't do much with it. So it's all about keeping it acceptable for the end consumer who are providing coverage for other people's devices, right? So it's all an acceptability thing. So what are the keys of capabilities of those networks? First, like broadcasting, those tracking devices broadcast a secure identity, but also the key thing, the key design element for those, and that's the one they've been like chatting about, is that smartphones can't be tracked by the manufacturer or malicious actors. If we look at the limitations of those networks, they don't really have a data channel. You can just send like those devices are only sending something which amounts to an identifier. And the other key challenge is that because they're using public key cryptography, that creates like some additional challenges because public keys are long. They use a lot of like bytes. I mean, not like still tens of bytes, but in the world of Bluetooth, it's a lot of bytes. So if you look at an advertising PDU, a legacy advertising PDU, and the number of bytes you can like put in it, it's it's not a lot, right? Like it's once you've like created a packet, you're talking maybe you have like 20 bytes to play with. But if you look at what's best in class in terms of public key cryptography, people usually recommend you use like 32 bytes like keys. But if you do the math, that doesn't really fit in the legacy advertising PDU. So they've like Apple, Google have found like some tricks to make it work. The first trick is that they use slightly shorter keys, so that degrades the security properties a little bit, but that helps. So they use like 224 bit keys by default. Still, that doesn't fully fit. So they found another trick. They're basically using the Bluetooth address bytes to transmit part of the key. So almost basically like it gives you almost 6 bytes to play with, like minus 2 bits, which are used for telling you which type of random address that is. But that's how they worked around like the fact that the public keys are long. Google has also a different mode for their spec, which uses maybe a cleaner solution, which is basically using external advertising to send the full 32-byte key in the advertising packet, which is obviously more elegant and much cleaner from standard perspective. But the issue is that not all Android phone will scan for extended advertising PDUs, so that kind of reduces the coverage. So it's not like fully in use, but hopefully one day that'll become more prevalent, and that really echoes what our previous speaker said, that ultimately like you're quite limited by what the mobile platform like can do or can't do. Now I want to talk about commercial asset tracking networks. So a slightly different scheme, like same like core technology. We're still talking about Bluetooth and still talking about like beacons being spotted by some infrastructure, but the requirements are a bit different, right? If you're like a brand or a manufacturer who want to track assets throughout a supply chain, then things look a bit differently to what you we need as a consumer, right? So you still usually need like some information about location. You still need to have like be able to associate identifiers with the assets you want to track. But there are two major differences, I would say, in terms of requirements compared to consumer networks, is that usually you might want to send data through that network as well. If you're looking at cold chain shipment, for instance, you might want to track temperature, right? And transmit temperature throughout the network, so that if your food parcel has been left in the sun for a day, well, you know that you should probably not sell that food and it's not edible anymore. The other key requirements is that that sort of provisioning or onboarding process that we talked about earlier, where someone has to manually register the device using like a paired connection and like onboard the device, and that takes a little bit of time. Like that's not viable in that world, because maybe you have like 10 AirTags in your pocket and you've spent 3 minutes onboarding them all, and that's fine. But if you're shipping like millions of goods every day, you can't like spend the same time like doing that onboarding. There's a lot of stuff which is happening in that space, which means that a lot of innovation is happening, and this is very exciting for companies like ours who support those Bluetooth beacon networks. First of all, there are like some companies these days making batteries which can be made using a printed process. So that creates a really like low cost, thin film batteries, and that's like a very recent innovation in terms of how that's come to market. Also, a lot of companies coming out making things that can harvest energy. For instance, like tiny solar cells that work really well indoors, which means you could like build devices that are build beacons that are powered by ambient energy, and those innovations enable new form factors. So something which at least we're hearing like a lot of excitement about, a lot of like our customers have started using and getting really excited, is the sticker or label form factor. You can do beacons that are in a sticker or a label, which is insane. And also, yeah, you have like the ecosystem is so huge in terms of beacon manufacturers that like you can find beacons for everything, right? Like this is a form factor for something that tracks a roll cage, right? You have things that can like stick on pallets, like this, everything, and you can walk the show floor and find a million form factors made by various OEMs. The silicon vendors haven't been asleep. There's been a lot of like cool announcements and releases of new products in the space, both on the really low end of the spectrum with the super cheap silicon that can that's a bit that features some basic functionality but extremely low cost and enables things like those labels, but also on the higher end of the spectrum where you have now like silicon that can run like quite complex ML models and enable like in that space crazy things like, oh, can I detect that my package is on a plane or being driven around, or like hasn't been dropped, or like things like that, where like you can run like really complex ML models on directly on those beacons, which is quite crazy. So in our company, we've been looking at all that innovation, and we've been working. We've been thinking what should be, like the right sort of system architecture, the right advertising format for those commercial asset tracking beacons. And that's not something we want to do in isolation. So we've been working with various partners who are making some of those stickers or some of those beacons, the silicon vendors, companies making handsets, things like that, to try and come up with something which we hope will evolve towards some kind of industry standard at some point. And today I want to focus on smart labels in particular, because that's the thing which is very new and which is driving a lot of that development we've been doing. If you look at the smart labels, the key requirements are around how will you assign, and I know it sounds a bit stupid, but how do you assign an identifier to it? How can any manufacturer decide, oh, this is label ABC, and I know I'm not going to conflict with that other manufacturer's label, things like that. The other thing we've been looking at is the whole security protocol and key agreement, in the sense where a manufacturer, how will a manufacturer communicate a shared secret with the end user or with the beacon platform they want to use, and things like that. The key difference with the consumer space that we've been looking at as well is that, like those like Bluetooth beacons, the commercial asset tracking space, or are not they don't operate in isolation. So there are a lot of like existing technologies around. Well, you all know the barcode, right? Like it's on everything, and also RFID, which is very prevalent in warehouses. So how do we come up with something that works well with those existing systems? Because logistics companies don't want to throw away all of the software investment they've made around those technologies and start from scratch or develop something in parallel. The last thing we've looked at is support for data, as I mentioned. How do we carry data across the system? And so the initial goal we had was supporting that IN100 chip. Why is that the case? That because like a lot of those label manufacturers, that's actually what they're integrating in those smart labels today, because that's very cost efficient. The trade-off that has a lot of like quirks and constraints. So if you're not familiar with it, that's like a silicon which doesn't have flash, so it just has OTP. So you have to program it in the factory and then leave it as such. It can only do TX, so it can't like establish a connection. Just lets you advertise, and it doesn't have like it's not programmable as such. Like you can configure it, so you basically say what you want to put in various advertising sets, but it's basically like a sort of configurable state machine, if you wish. It does have like a security engine, which is good. That being said, like we don't want to be like IN100 specific. Obviously, like we want that format to be extendable to other silicon. And as I said, like the key thing is that we want to engage with other people doing like working in that space, be it like suppliers, partners, silicon vendors, and even competitors, because we think that this is an emerging market, and that's one part of the pie where we think that if it's a shared standard, we can all benefit from it. So what did we come up with in terms of what to put in the advertising frame? We try and keep it as simple as we could. So first, like have like a unique ID, which is like just 6 bytes. In the frame, you'll notice that it's not like some kind of like rotating identifier. It's because like you don't have the same like privacy requirements in a supply chain as you would have like for consumers. Then we have something which is a frame counter, which increments every time an advertising packet is sent. I'll explain why we use that. Then 6 bytes for data, an authentication code which authenticates the device and the data that's being sent, and then like a frame type, which is basically a version byte, which can increment so that we're kind of future-proof. How does the setup work? Well, a lot of stuff happens on the manufacturing side. So the manufacturer who's making those labels will generate an identifier for that label and a secret key, inject it on the device, and then the beauty of it is that it can provision that tag with one or multiple beacon networks. Today it works with Beacon, but it could work with our competitors as well. And then the other thing they do is print a QR code on the label, which will allow the end user to sort of claim ownership of that tag, and the Beacon platform can sort of like associate at that point the tag, the sticker or the label with that specific user. And that means that the association or the onboarding process for whoever's going to use that tag has been greatly simplified. They just like basically scan the thing and that's it, it's on their network. So the overall architecture is quite similar to what we've seen before. The beacon is still transmitting an ID. It's also transmitting some data. And then we still have like handsets around that can spot those beacons, and they have location information. They send all of that to a beacon network platform, and then the consumer or the owners of those beacons gets a stream of events. That icon on the right could just be another cloud icon, because usually that goes into the ERP system or some kind of like existing asset management system that they've got. In terms of crypto scheme, this one was quite driven by what that specific chip could do, but the principles like will scale. We've got a device key, which is unique per device, and then as input to the authenticated encryption engine, which is AES EAX in the case of that chip, we use the advertising counter, which is so it increments every time something is sent, and we also have the data that we want to send as an input, which can be temperature, things like that. And then as an output, we get the encrypted data, and we get like an authentication code. And you might ask why we have the advertising count as an input to the engine. It's because we want those tags to be unspoofable. So the first time one of those beacons is spotted, we record the advertising count, and then we know how quickly it's meant to increment. And so when we see the tag again, we see if the advertising count roughly matches what we expect. And if it's too old, that probably means that someone's trying to do something a bit nasty and try to spoof the tag, and we can reject the advertising packet. So I've mentioned other technologies and how this doesn't happen in isolation, and quite a lot of people in the space ask, okay, how does that play out with RFID, for instance? Well, if you look at like the existing state-of-the-art technologies in the asset tracking space, well, you have the barcode, which is everywhere, which is super low cost, but usually requires like a manual scan or some infrastructure with like cameras and things like that to scan things at scale. And then you have RFID, which is still pretty low cost because you use some optimized like printing processes to make the inlays, but requires quite a lot of heavy infrastructure. So the reality is that RFID is quite present in warehouses, but not very much outside. And that's why there's a strong opportunity with using those Bluetooth beacons in supply chains in logistics, because usually what happens today is that once an asset leaves the warehouse, people lose visibility over it. So there's great visibility of what happens within the warehouse, but not much outside. So even though a Bluetooth beacon or sticker will cost more than an RFID tag, the key difference is that it doesn't require new infrastructure. So someone who's going to work with a tracking company can't really mandate them to install of RFID gear within their trucks because that's cost prohibitive, and maybe they're not going to use them next week. But they can ask them, hey, you have a Zebra handheld device, you have a mobile phone, can you make sure your drivers install that mobile app across that supply chain, and then I get coverage without any other investment beyond that. So it's like just infrastructure as software, and you're really leveraging the ubiquity of like Bluetooth enabled handsets. That's why this is like super exciting. And so in practice, that's how we've seen like people using those two technologies together. They tend to tag like individual packages or assets using barcodes or RFID in the warehouse, and then they collate them together in a shipment unit, which can be a roll cage or a pallet or something like that. And then they tag that unit with a Bluetooth beacon, a Bluetooth sticker, and then that thing leaves the warehouse together, and then they can track how that pallet or that unit is going through the supply chain by having enabled a Bluetooth network on the handsets of their drivers or their third-party logistics providers. And all that data coming from the RFID system and the Bluetooth system coming together in the end in their ERP. So it's like a new data source to an existing data system. So what does it look in practice? So that's a company in the UK that we work with. Like they have like a fleet of trucks, and they like move pallets across the UK. So they've been using those labels to tag shipment on pallets. So they just peel them, scan them with a Zebra device. That means they can associate it with the right asset, and then they put it on the truck, and the truck leaves their warehouse. And the beauty of it is that in terms of infrastructure investment, it was zero. They all had like Zebra devices on their mobile device management, so they just pushed like a new app to those, and overnight they could get some visibility across their supply chain outside the warehouse. That's a dog fooding exercise we did a few months ago. We drove to Germany from Cambridge to attend a trade show, so we put like a bunch of labels on like our booth, like, and gear and things like that, and put it at the back of our van. And that's the kind of like data we got with like temperature and like various like events, and then like you see we've been in other places as well. That's it for my presentation. We also have like a white paper that we published. It goes into a bit more details in terms of what you can do with those smart labels and why we think that's quite life-changing for those industries. I'll be very happy to answer questions at the end, and I'll be at the Zephyr booth from 3 p.m. as well if you want to find me there. Thank you.